everyone, and welcome to this video on knowing properties and graphs of some basic functions. Okay, so in this video, I've pulled some basic functions from an intermediate algebra text. So this is not an exhaustive list by any means. There are plenty of other classes of function out there that you could be learning about. I just have a list of 6 of them that I'm going to be going over that again I saw in an intermediate algebra text. So that's the scope of this. And even the properties from this table of functions I'm going to be showing you, even the properties are limited to just a basic algebra understanding. The properties could be added to and will be added to in a future video. Right? I will be doing a video in the future with a more in-depth look at these basic functions, but for right now this is just an introduction to some properties and graphs of some very basic functions. Alright, so let's begin. So the first of these is the your basic linear function. Alright, and I've already, now I'm not going to be doing a lot of writing here, just I have everything pretty much written out already. I'll just be following along. So your basic linear function, which takes on this form, f of x or y equals m times x plus b, where x is the input, the independent variable, f or y is the output or dependent variable, m and b are real numbers. So for instance, f of x equals 2x plus 3, or negative 5x plus 7, negative 2x minus 4 plus negative 4. You can think of all sorts of examples of a linear function. Okay, so some properties that a general linear function has. First off, the domain is a set of all real numbers, meaning I can plug in any number I wish, any number on the number line for x, and get a real output. And the range is also the set of all real numbers, meaning that every value on the y-axis is the y-coordinate of some point on the graph, right? Every value on the y-axis is an output for some value on the x-axis. Right? So the domain and range are all real numbers. The graph will be a non-vertical line, right? A vertical line is straight up and down. So the graph of a general linear function of this form, y equals mx plus b, f of x equals mx plus b, is non-vertical with a slope of m, right? So the coefficient of the x in this form, the m is the slope of the line, right? And slope generally gives you how fast or how steep a line is, and also in what direction it is going. And I'll discuss more about slope when we look at the pictures. Slope of m and a y-intercept of that'll be the point 0, comma b, or an input of 0 will give me an output of b, which you can see here. Anything times 0, if I replace x with 0, right, 0 for x, m times 0 would be 0 plus b, I get an output of b. The value of f at 0 would be b. This point is the point of the graph that's on the y-axis. That's the name, the y-intercept. Alright, and then the general graphs of these things, these linear functions. I broke it up into 2 cases. One where the slope is a positive number, so f of x equals mx plus b, where m is a positive number, m is greater than 0. Alright, so if a line, right, a linear function has a positive slope, the graph of that line will go upward as you move from left to right, will rise as you move from left to right. Okay, and then what does slope mean? Right, when you say the slope of the line is m, all that means is if I were to go from one point on the line, say this point here, to any other point on the line, so I just pick any 2 points, these 2 here or these 2 here, and travel from one to the other, going just up and down and left and right. So if I travel up and then to the right here, the amount traveled upward is sometimes referred to as the rise, right, or the vertical change. That's R-I-S-E. Sorry, that's pretty tiny. I'll make the next word bigger. And then the amount you travel right or left is called the run, or sometimes the horizontal change, or the change in x. And the slope, and this is a very quick overview of slope. If you want to look for other videos out there on slope for more detail, please do. But the slope of a line is, if I travel between any 2 points going up and down, left and right, the amount I traveled up and down, the rise, divided by the amount I traveled left and right, the run, that ratio will always be the same. And it'll always be equal to whatever this number m is. Alright. So if I go from this point to this point, the up distance divided by the right distance will be m. If I go from this point to this point, the up distance divided by the right distance will be m all the time. And that's what the slope is. And notice, that I have the point, 0 comma b here. So this is, b. I know it looks like 2 units, but it really could be anywhere, as long as if the line's going up like this, up to the right, it has a positive slope, and b is simply the y coordinate of the y-intercept, the place on the y-axis where the graph will cross the y-axis. All right. And then the other case is, f of x equals, mx plus b, but where m is negative, m is less than 0. So a line with a negative slope will move downward as you move toward the right. If I go from left to right, the graph of the line goes downward, descends, if you will. Right, and the same thing when you're talking about the slope being m. You take any 2 points, this point and this point, it doesn't matter. You take any 2 points and travel from one to the other, going up and down, left and right. I was going right. I'd go down this far and then to the right this far. Again, the amount I went down is the rise, and if you go up, it's a positive change. If you go down, that's a negative change. So I'd call that some negative quantity. And then the amount I went to the right to get to that point on the line would be the run. And same thing, the rise divided by the run. The amount moved up or down divided by the amount moved left or right to stay on the line will always be this value m, will always be the same thing, no matter what 2 points you pick. Alright, that slope. Okay, so you see how graphs of lines look. Linear functions in this basic y equals mx plus b form. Alright, so get that in your head. Now, the next 2 types of function I have for you are just special versions, special types of a linear function. The first of these is called the identity function. So again, it's a special type of linear function. So it's got this f of x equals mx plus b form, but it's very special where the value of m is 1, so 1x plus, and the value of b is 0. So f of x equals 1x plus 0, or just simply x. Right? This is the same thing as 1x plus 0. So f of x equals x, or y equals x. So for this particular linear function, you're seeing that the input x is the same as the output f of x. So for every single ordered pair on my graph, every single ordered pair relationship in this function, the x coordinate is the same as the y coordinate. The input is the same as the output. Alright, and as before, since this is a linear function of that form that we saw in the first page, the domain and range are the same as any linear function. The domain, any non-vertical linear function. The domain and range are the set of all real numbers. I can plug in whatever I want for x, And because the output's exactly the same as what I plug in, the output can be any real number as well. So the domain and range are all real numbers. This is the graph of this identity function, just simply f of x equals x, is a line, right? I said it's a special type of linear function. So the graph is a line, and the value of m here is 1, right? I mentioned that already too. So that with a slope of 1, so that rise divided by run, that vertical change divided by horizontal change will always be 1 between any 2 points on this line. The y-intercept, or just the intercept, right, because it's also on the x-axis of this graph, will be the origin, the point 0, 0, input 0, output 0. And the line consists of all points for which the x-coordinate equals the y-coordinate. We see the graph of this function over here. Notice I have input 0, output 0, input 1, output 1, input 2, output 2, 3, 3, 4, 4, 1 half, 1 half, 2/3, 2/3, 2.5, 2.5, will be on this graph. -1, -1, -2, -2, -3, -3, and so on. Every single point here has the same x-coordinate as it does y-coordinate. Right, and it's got a slope of 1, right? Because if you take any point, go to any other point, the rise divided by the run will always be 1. All right, so basically the rise, no matter what 2 points you go between, the rise and the run, the slope, right, the rise and the run are going to be the same number. You'd have here I went up 3, right 3, it's 3 over 3. The rise over run will always be equal to 1 for this particular function, this particular line. Okay, so you have the general idea of what any non-vertical linear function looks like. You also have an idea as to what a simple identity function looks like, just where the output has the same identity as the input. I guess you could say it that. You could say that the input keeps its identity; it doesn't get changed. For the output, maybe that's why they call it the identity function. And we got some properties for those. All right. My next type of basic function is another special kind of linear function. All right, so it's still going to have a graph of a line, and that's this here, the constant function. All right, so I'm going to go back to the way a linear function looks. Remember, it's f of x or y equals mx plus b, m times x plus b. This constant function is another special type of linear function. So it's got this form, but this time the value of m, the slope, is 0. Alright, and then the value of b is just any real number. So what we're getting here is f of x equals b, or y equals b, where b is a real number. So, f of x equals 2, f of x equals 7, f of x equals, -5. It's just y equals some number, some constant. There's no variable over here. There's no input. There's no x. So the output is always the same number. The output is always this b, no matter what I plug in for x. All right, so noting that, some properties, the domain is, again, because it is a linear function, the domain is the set of all real numbers. But this time the range is not all real numbers. Right? The range is the set of outputs. But as I said a second ago, the only output for any value of x, the only output is the number b. So the range has just the single number b in it. It's just the number b, the set with b in it, whatever b is. And the graph is a horizontal line, right? So it goes straight left and right, kind of like the x-axis is a horizontal line. It goes straight left and right with a slope of 0, and that's what they say a horizontal line is. It's a 0 sloped line. And the same type of y-intercept, when I plug in 0 for x, I still, I always get an output of b here, so the point 0b is on the y-axis. Alright, so I've got a little picture over here for you, a generic picture of a horizontal line, a line with a slope of 0. F of x equals b. And it's just again a horizontal line going straight left and right, and I just plotted a few points. The y-intercept 0, comma b, but here's 4b, negative 3b, negative 4b, negative 1b. You got 2.5b. Every single x coordinate corresponds to a y coordinate of b. Right? The y coordinate is always b. Y equals b. F of x equals b. All right. And when talking about slope, the slope being 0 again, and you take any 2 points on the line, and you can't go up and down. I would just go straight to the right or straight to the left. So the rise is equal to 0. All right, so that means that rise divided by run, there is no rise. There is no up and down. So rise divided by run, the rise is 0, and the run is going to be some non-zero number. All right, again, this is just a run here. So remember, 0 divided by any non-zero number is 0. Right? So you see in our slope, the value of m here is 0 for a horizontal line. Okay, so those are the most basic of basic linear functions. You have that y equals mx plus b, where m is the slope, b tells you the y coordinate of the y-intercept, the identity function y equals x, line with a slope of 1 and a y-intercept of 0, and then this horizontal line, the constant function, just y equals b, y equals 2, y equals 7, y equals 10, right? And a slope of 0. Okay, so those are the basic linear functions in this particular algebra text I'm referring to. Then we kind of bump it up a bit. Instead of having our variable to the first power, now we're going into the square function. Right, f of x equals x squared, right? X to the second power. So input x, the output is x squared. All right, so in this case, the domain is still the set of all real numbers. I can still plug in any input I wish, right? You can take any real number on the x-axis and square it. That's fine. You're never going to divide by 0 or something there. Right? You'll have a real output. But the range, however, is not all real numbers. Right? When you take a number, take a real number and square it, raise it to the second power, multiply it by itself. Remember, x squared just simply means x times x. You always end up with a non-negative number. For instance, 3 squared, right? 3 squared is 9, positive. 0 squared is 0, right? 0 times 0, that's not negative either, right? Negative 1 squared is negative 1 times negative 1, and remember, a negative times a negative is a positive quantity. So negative 1 squared is positive 1, non-negative. So the range is the set of all non-negative real numbers, right? So no negative outputs. And the intercept of the graph, the point that's on any of the axes, is the origin 0, 0. And here's a graph of it. Now notice this is not a straight line, right? I've plotted some points for you, right? 0, you have 0, 0, 0 squared is 0. You got 1, 1, right? 1 squared is 1. You have 2, 4, 2 for the x, 4 for the y. 2 squared is 4. 3 squared is 9, right? You got the point 3, 9. Negative 1 squared is positive 1. You got negative 1, 1. Negative 2 squared is positive 4. You have negative 2, comma 4. Negative 3 squared is positive 9. You got negative 3, 9. And you see what we're getting here is this like U-shaped graph, right? Following the pattern of all these ordered pairs, all these points. And in fact, this particular, for the squares, when you have a variable, one variable squared and the other variable is not, this has a special name. This is called a parabola. This type of graph where one variable is squared and one is not, this U-shaped graph here that goes up forever on both sides. Okay. So, and this is the most basic parabola. Y equals x squared, or f of x equals x squared. And in fact, you'll see in future videos, every other parabola is just that opens up or down, like this one opens up, opens upward. Every other parabola that opens up or down is simply a transformation of this basic parabola, and that's really why you are asked in a lot of texts to learn about the basic functions. What's the basic linear function? What's the basic parabola? What's the basic square function? Is so that later, when we see more complicated functions involving a square, like 2x squared plus 3x minus 8, you'll be able to graph that more complicated function starting with the basic function and then performing some transformations, right? And there'll be videos in the future, or you can search for videos on your own right now on function transformations. Okay, but for right now we're just learning, again, these basic functions. So here's the basic square function, very simple. And then bumping the power up one more notch, number 5 here, I have your basic cube or cubic function, the cube function. F of x, or y, equals x to the third power, right? X cubed. Y equals x cubed. And remember, this means x times x times x, right? It means to raise to the third power. Alright, so again, I'm not going to be dividing by 0 or anything when I plug in a number, so the domain is all real numbers. I can plug in anything I want for x. The input is x, the output is, x cubed. The range is also the set of real numbers, because this time, when you cube a number, it can be positive or negative, right? It's not like squaring. 1 cubed is 1 times 1 times 1 is positive 1. 2 cubed is positive 8. 2 times 2 times 2. 0 cubed is 0, which is neither positive nor negative. But then you get into the negatives. Negative 1 cubed is negative 1 times negative 1 times negative 1, which would end up being negative 1, a negative number. Negative 2 cubed would be negative 2 times negative 2 times negative 2 would end up being negative 8. So you can end up with negative outputs, positive outputs, or 0 as an output. So domain is all real numbers, and also the range is the set of any real number, all real numbers. And the intercept of the graph, the only point that actually is on any of the axes, is the origin. Again, here 0 cubed is 0, 0 comma 0, the origin. And here's a graph of it over here. All right, again, not a straight line or anything, and not a parabola. So you see, 0 cubed is 0. 1 cubed is 1. You got the point, 1, 1. 2 cubed is 8. 2, 8 is on the graph. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. Right, and you'd have 3, 27, negative 3, negative 27, and so on. And you could plot all the, and you get this pattern here, this blue curve that goes up forever to the right and down forever toward the left. But you can hopefully see from the picture that the domain and range is all real numbers. All right. And then, as I said with the square function, the reason you're learning about this cube function, this basic cube right now, just simply y equals x cubed, is so when later you're looking at more complicated functions where the third power is the highest power, say 2x cubed minus 5x squared plus 4x minus 3, some crazy polynomial where the highest power is the third power, you'll be able to graph a function like that starting from this basic one and then transforming it. Alright, so again, I'm not going to get into that in this video, function transformations, but in the future I will. And you could also, again, look up other videos. Just look up function transformations and some interesting stuff will come up. Alright, so there's your basic cubic function and some properties. You have your basic square function, linear function, identity function, constant function, all three types of special types of lines. And then my final one here for this particular video is the absolute value function, right? The basic absolute value function, where f of x equals, remember these symbols mean the absolute value of x. So input x, and then the output is the absolute value of x. Now absolute value is simply the the non-negative distance from 0, or on the number line if you want to think of it that way. So if you recall, the absolute value of 5 would be 5. The absolute value of 7 would be 7. The absolute value of 0 would be 0. The absolute value of -1 would be +1, right? Because it's 1 unit away from 0. The absolute value of -3 would be +3. It's, because -3 is 3 units away from 0. So the absolute value of a number is never negative. So it's kind of like square, right? When we looked at that square function. So the domain here is, all real numbers. I can plug in whatever I want for x. My input can be anything. It's the output that can't be anything, right? The range is the set of all non-negative real numbers, right? The absolute value of x will never be negative. So you'll never have a negative y coordinate for points on the graph of this function. The intercept is 0, 0, right? The absolute value of 0 is 0, so 0, 0 will be on the graph. That's on both the x and y axis. So that's the intercept. And then here's some stuff that, this is just basically how absolute value works. So if x is, greater than or equal to 0, so if x is not a negative number, right? If x is not a negative number, then f of x equals x, meaning that the absolute value of x is just x itself when x is not negative, right? As I was saying before, pick a number that's not negative, like 5. The absolute value of 5 is simply 5, right? The number I'm replacing x with. 10, right? The absolute value of 10 is simply 10. That's all this is saying. When I say when x is non-negative, then f of x is just x itself. So that, remember, this is that identity function. So you're getting a graph of f that is part of the line y equals x, just part of, I'll underline that here, just part of the identity function, but only when the value of x is non-negative. And that would be this part over here, right? On the x-axis, that's from x equals 0 to the right. This is the part of the graph of my coordinate plane where x is non-negative, x is greater than or equal to 0. And over this part of the x-axis, you see my graph is part of that y equals x line, right? That identity function. So you have 0, 0, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2, so you got 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Just this part of it, though. All this way forever, just part of the identity function. And then the other way around is, well, what if x is negative? What if I plug in a negative number here? If x is negative, if x is less than 0, then f of x is, -1 times x, or the opposite of x. So think about that. Pick a negative number, say like -5. What's the absolute value of -5? Well, it's not 5, it's not x, it's +5, right? The absolute value of -5 is the opposite of -5. So that's why there's a minus sign here, positive, which would make that +5. Pick another negative number, -7. Plug in -7 for x. What's the absolute value of -7? It's the opposite of -7. It's +7. So that's why I'm saying here that y equals the opposite of x, negative x, when x is less than 0. And that's on this part of the coordinate plane, right? When we're to the left of the origin, left of 0 on the x-axis, this part of the x-axis has values of x that are less than 0. And over this part of the x-axis, we're getting a graph that's part of the line y equals -x, part of the line that has a slope of -1 and has a y-intercept of 0, 0. That's this line here. Right? And again, only part of it, right? Just up to the origin and not beyond it, because it's only the part of it that has x coordinates that are negative. And again, make sure that it works out. The absolute value of -1 is 1. The absolute value of -2 is 2. -3 is 3. The absolute value of -4 is 4. You have all those ordered pairs on that part of the graph. All right, and so what we're getting here for this basic absolute value function is like a V shape, right? A nice V-shaped graph, or a bent line, if you want to think of it as a line that's bent, you know. Either way, this is the way the graph of the absolute value of a linear expression, right, x to the first power expression will look. It'll look like one of these V shapes or a bent line. And as I've been mentioning, the reason you're learning about this basic absolute value function right now is that for later functions, you know, you're going to look at something a little more complicated. Perhaps the absolute value of, you know, not just x, maybe the absolute value of, you know, 2x plus 3, some other linear expression. Well, what you're going to see is that the absolute value of a linear expression is just going to be, you can start off with this basic one and then perform function transformations to get the more complicated looking one. All right, so that's all I have for you today. As I mentioned at the beginning of this video, these were all taken from an intermediate / beginning algebra text. So there are plenty of other classes of functions out there. All right, we haven't touched on, you know, your basic reciprocal function, your basic rational function, your basic logarithmic, exponential, you know, hyperbolic, and then there's, like, you know, sine, cosine. There's the trigonometric function. There are plenty of other functions out there, all right, besides these 6 classes I've brought up here. And same thing goes for the properties. You know, the properties mentioned in this video are just a basic list of properties of these functions. We haven't talked about where these functions are increasing or decreasing, concave up, concave down. There's lots of other properties you could talk about when it comes to a function. You know, are they even or odd? You know, and again, you don't know what that means, or maybe you do, but those will be gotten into. I will get into those. I will dive into those topics more deeply at a later date in a future video. All right. But yeah, just get to knowing how these look. Right, your basic linear function, identity function, the constant, you know, horizontal line, your basic square, basic parabola, basic cubic function, and your basic, you know, V-shaped graph here, the absolute value of x, absolute value function. Okay, and as I like to say at the end of these, you know, try your best, do the best you can to understand and get the material on your own. Learn it on your own before you go looking for help, because I find that material tends to stick with people longer and better when they've taken the time and the effort to learn it on their own. So read the material, of course, read through the author's examples, perhaps even try to work out the solutions to an example before you see how the author did it, and then compare your work to the author's and see where you can learn from any mistakes. Of course, work on exercises, extra problems, practice problems. Look up answers when they're available to check yourself, track your progress. And don't just give up after the first approach, the first attempt. You know, try several approaches at a problem before you decide that you got to do something different. You know, if after several approaches at a problem you're still not understanding how to do it, you're still not getting it, perhaps you should read through the material again, maybe even a third time, because you might have missed something. Maybe read it more deliberately, more carefully, take your time, and perhaps, you know, the second or third read through you'll see something that you didn't see before, or something will click that didn't click before after having worked on some problems already, and it'll make the homework that much easier. But if after that, you know, if after reading the material several times and working on the problem, approaching the problems in several ways and several times, you know, if it's still not clicking, still not getting it, well, then it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for. Ask a teacher, a tutor, a friend, someone else in the class who you know knows the material well and is willing to help. Look for supplemental materials online. There's plenty of stuff out there, I assure you. Look for videos on the topic you're trying to study. Perhaps like this one, or plenty of other ones out there that are better than this one. I know you can find them if you do a simple search. They're out there. And just keep at it. Stay persistent. Keep practicing. Don't give up. And try to have a positive attitude. That's the hardest part, I know. People tend to say they hate math. I've always hated math. I can never learn it. I can never learn it on my own. Well, you're probably going to continue to have that problem if you keep thinking that. It's amazing the difference attitude and mindset can make. So try to go into things with an open mind. Saying, I'm going to learn something today. I'm going to enjoy learning this. I'm going to put my best foot forward. Stay positive. Have fun. Enjoy learning. It's amazing the difference that could make. Just having a positive mindset. Easier said than done, I know, but give it a try. So stay persistent, keep practicing, stay positive, don't give up, and I know you'll eventually get it. And thank you for watching.